further ado, we start with the first presentation from University of Hasselt. Stage is yours.
Okay, welcome everyone at this session of Graphs and Network Models. I'm the first presentation. I'm Leen. I'm from Hasselt University, and I will be presenting my work on mining valuable collaborations from event data and evaluating them using a marketing principle called the Recency Frequency and Monetary Principle. Okay, so first I start with a short introduction on what you can expect from this presentation. So what I did is I made a tool that can extract from the kind of data that you see on the right. It's called event data, where we have an event where a resource worked on an object at a certain point in time. And this tool can extract a network of how these people collaborated on these objects. And I will evaluate both the resources and the relations based on recency, frequency, and monetary. So why? We all know that collaborative work improves organizational performance, but only if those teams are well implemented, well managed, and well supported. And to do that, to improve collaboration, you have to know how your team is really working. You have to know the truth. Now, literature has shown that a team leader's view on collaboration often does not really match reality. So luckily, nowadays, there are more and more tools that support collaboration in the digital space, such as, you all know, Google Drive or Slack, you have GitHub, you have all these kinds of different systems that keep track of when someone worked on what. And from these systems, you can extract a way more objective and data-driven view on this collaboration behavior. So the data structure you can find in these systems is called an event log. It's a term from process mining. In process mining, you have a log with events on activities in a process. Here, it's only necessary to know the resource, on which object they worked, and at which point in time. So these are the minimal requirements that you need to keep track of to be able to mine such a collaboration network. Okay, of course, I'm not the first one to do something like this. There is a lot of literature on mining networks. You have organizational network analysis, you have the organizational perspective in process mining, and you also have developer social networks. But they all have some kind of limitation when it comes to my context of collaboration. And I will briefly highlight what I think did not match with my case. So first we have organizational network analysis. The problem with this is, the question is, can it deal with this kind of event data? Organizational network analysis, the existing techniques expect to get the collaboration relationships directly in the data. Well, this is not the case when you look at this kind of data. We don't have really data about collaborations. We only have data of who worked on what at which time. So we need some kind of method to discover these relations between these people. So that's a first mismatch. Then we have the organizational perspective on process mining. Process mining, for those who don't know what that is, it deals with events on a process that are captured in a process-aware information system. And they try to get insights on the process. For example, the process flow. And the mismatch with this is that they do not always have a comparable view on collaboration as in my use case. So for example, they look at activities that follow each other, and the first activity is executed by one resource, the next by another, and they call that handover of work networks. That is not really collaboration, in my opinion. They also look at resource profile similarities, so resources that carry out the same type of activities, so they have the same type of profile, but it's also not really collaboration. And lastly, we have developer social networks. It's a subdomain under mining software repositories. So they have literature on extracting a network of developers who developed software code, and they worked on this together. But a problem here is they use often a definition to make these networks that state like two developers worked on the same source code file, so that is collaboration. But what if one of those developers worked on April 28th, and the other one worked on December 11th? I would say that is not collaboration because it's way too far apart in time. So there need to be some constraints, such as, first of all, the time window which this collaboration took place, or the granularity, like working on one object or working on a dozen files is not the same. Okay, so all of these also have in common that they have no clarity or agreement on what constitutes a valuable resource or a valuable relationship. If they use something, it's often the frequency at which someone worked, of some pattern appeared. So the new idea in this research is we can use this principle from marketing. It's used to assess customer value based on 3 dimensions. You have recency, you have frequency, you have monetary. So it looks at an event, how recent the event took place, how frequently it took place, and some kind of monetary aspect of the event. There is, of course, some related literature. There is no really related literature that incorporates these dimensions in the context of collaboration network, and also none for social network discovery algorithm. But there is some work on RFM-enriched networks. I will not really go into detail. I will very briefly highlight if you're interested. The work that lies closest to mine is the one of Mitrovic et al. And they use telecom call graph in which you have customers who call, and they use these RFM information as explanatory variables for churn prediction. And you can see those recency, frequency, monetary, you can adapt them to your use case. So in this case, the recency would be the time between a customer's last call and the observed period, frequency, how many calls they made, and monetary, for example, the duration of the calls. So you can adapt this. They had 2 approaches, if you're interested, one on RFM embedded graphs and one on RFM augmented graphs. Both do not use RFM for edges between nodes, so for relations, which I wanted to do. And RFM embedded, for example, looks at, you have RFM values for 2 customers, and they use the distance between these 2 metrics to value the edge as a summarized value. I'm trying not to summarize this. And RFM augmented graphs add artificial nodes that indicate the RFM segmentation. Also not trying to change the topology of the graph. Okay, so let's get into what I exactly did. My research objective starts with an event log structure, as you've seen. And the idea is I wanted to build an algorithm that could extract this collaboration network from this data using some realistic constraints like timing and granularity, and evaluate these on the RFM dimensions. And I will get into the algorithm design. First of all, there's an important remark to make, and that is we rely on the assumption that a resource can log their work or save their work as often as they would like. So you have on the top, for example, a woman who worked on a JavaScript file, and she did this, she saved this in 2 times, and she worked on some more files, and then she had a couple of working elements on a PDF file. Well, the man on the bottom, he just did everything and then saved it all at once. So consequence is that we cannot look at the amount of times something is tracked and say, okay, this means that the woman worked more than a man, because that might not be the case. She just had a different logging style. So what we need to do first is kind of group these events together. So for example, now we can see that the woman had like 3 work sessions and the man 2. This also has an impact on how we calculate collaboration behavior, because you would think that the woman and the man collaborated 4 times on those first files, while in reality it was just 1 session. So this means that the first step of this algorithm is I want to actually construct work sessions for each resource, and I want to construct collaboration sessions for each resource pair. Afterwards, we can mine the collaboration relationships and calculate these RFM values. How is this done? This is a realistic example with real data on someone who tracked their work, and you can see the color code is what is grouped together. How is this done? We start with this log timeline. You have a woman who worked on a lot of objects. It doesn't really matter what those objects are, but there are 2 parameters that must be set by an expert. And these are T minus and T max. And this means T minus is the time between 2 consecutive events. If it's bigger than this T minus, then it must be a separate session. For example, if there's 2 weeks between them, you cannot call that the same work session. And we have another T max is the maximum duration of such a session. For example, you know that a resource cannot work for 2 days straight because you need to sleep, you need to eat, there have to be breaks. So how does this algorithm work? We position them all chronologically on this timeline. We split if the gap is bigger than this t minus, so we get some kind of windows of events. And if such a window is still too big to be one session, we have to recursively split it again. So we search for the largest gap and we split it again until it's small enough to be a representative session. Okay, so now for this woman has 1, 2, 3, 4, 5 work sessions. The calculation of the collaboration sessions is done similarly. You have this timeline. We look at collaboration on one object. So we have the timestamps of when the woman works on some objects, which are the purple markers, and some men, which are the orange markers. We use the same kind of algorithm. We split when there is a gap, and we split again. And then we get several windows, and the question is, when did they collaborate? They collaborated if they worked on the same file within a reasonable time span. So in this case, we have like 3 collaboration sessions. We have the first, somewhere in the middle, and there at the end. Then we're at step 3 of the algorithm, which is we make a network, and we have to decide, is there a relationship between 2 resources? There is one if they engaged in at least 1 collaboration session. So we saw from the previous slide that they had 3 collaboration sessions, so they should be connected in this graph. Okay, so now we have the general graph structure. The last step is to calculate some recency frequency monetary values. This is done as follows. So recency would be how recent a resource has worked. Frequency, how frequently did they work. And monetary is some kind of the monetary value of the work packet, so the importance of the work that they did. How is this calculated? We start with the recency for a resource and a collaboration. So for a research, it's how recent do their sessions fall on the log timeline, and the adaptation for the collaboration sessions is how recent do the collaboration sessions fall on the log timeline. So we have a log timeline, we have a start and end, and we divide this into several windows of equal width. They all get a number from 1 to the number of windows, and a weight, which is equal to the window number over the total number of windows. Which means that the weight of the least recent is smaller, it's the smallest, and the most recent is bigger to 1. So we then have a set of work sessions or collaboration sessions, and they all take place somewhere on this timeline. We get them back where they belong based on the median of the events in such a window. And then we can take a weighted sum. For example, we have 10 sessions on this timeline, 1/10 times the weight of the window, 1 on 8. And we summarize this to 2 on 10 have a weight of 3 of 8. And then we get like a value that represents the recency of this resource. So if they worked or collaborated more recently, only recently, then the value would be greater to 1. If it's only at the very beginning of the project, value will be closer to 0. Okay. So the next one is the frequency. How frequently did resources work? It's just counting the number of work sessions they did. And how frequently did 2 resources collaborate? You count the collaboration sessions on each object. And then we're left with the monetary value. It's the importance of a resource work packet, which means the number of times they worked on an object times the importance value of this object. So we need the number of times to distinguish between, for example, if we look at collaboration, someone who collaborated once on a very important file and 9 times on less important files versus a pair that always collaborates on the most important objects that are of the project, and then once on a least important object, and they would have the same value, monetary value, and that does not make sense. So we need to know how often they collaborated. Now, this importance value is very hard to set. So it's very project dependent. So normally, ideally, it will be given as a log attribute or some kind of user-defined function. We have a default value, which is based on an object is important if it continues to grow over time. So it's important for collaboration, because an object that's frequently worked on, if multiple people have knowledge of this, then it secures its further evolution. But this is not always the case for every project, so you really have to think like, what can I use as some kind of importance value for my use case? Then I would like to show you a little demonstration. I had some data on machine learning. So it was a course on machine learning, and you had different authors and illustrators who made lessons on different machine learning techniques and so on, and what machine learning is. And then afterwards, it was made available for the public so they could translate it into other languages or fix some kind of bugs that were still in there. And before I show you the network, I will show you some results on the RFM dimensions. Now, traditionally in the marketing field, it is used for customer segmentation. So this means you have different ranges of these dimensions, and they are segmented in this case from 1 to 5, so you have segment 5 would be the most recent or the most frequent and so on. And for example, some sneak peeks of things you can see here. You can see there's one resource who has a very high monetary value. You can also see that there are only 2 resources who have a very high frequency level, and very few resources who worked only at the beginning of the project, so are in segment 1 of the recency. And we'll show you this in graph form. So I mined this graph, and you can see here the node sizes and edge sizes represent the monetary value. So it's color-coded. You have the authors are in blue, you have the illustrators in green, translators in purple, and so on. A first thing that you may notice is we have this core of authors and illustrators, and they are all very big nodes, which means if you look at the data, they have a large monetary value. They also have a relatively large frequency value, but very low recency. So this means they worked at the beginning of the project on very important files. And if you think about it, this makes sense, because they created the lessons, and the lessons is what the entire course is about in the beginning. And afterwards, they were made public for translation. So it's logical that they have a low recency value. You can also see there's a very central node here. Almost every node is connected to that one in the middle. It's a project lead. Another thing you might notice is we have these 2 translators who unexpectedly have a large monetary value. So they worked on a lot of important objects, which means they translated almost all the courses. But you see, they do not collaborate with anyone, so they did it all by themselves. So it might be important to take a look at these resources and see, for example, for knowledge retention, if you lose those people, then you have no one who really knows what those objects are about anymore. There's also a group of bots. You can see those black dots. They are not very high on monetary. They are not very high on recency and frequency. They are only used at the beginning to initialize the project. Okay. If you look at recency, so now the node sizes are the recency, you can clearly see what you expected. All these bug fixers and translators have very high recent value because it all happens at the end of the project. You can also see there's one author who clearly added another lesson in the later stadium. So on the top you have this resource 11 who is way bigger than the other authors. Okay, so that were some insights on this demonstration. I will conclude with some limitations and future work. First of all, this method for object importance, as I already said, it is very project specific. It's hard to give a default method. So for example, if you apply the current method to software engineering, it would point to files that had frequent bug fixes, for example, but not necessarily contain the feature criticality. So you have to adapt this to your use case, and it's very hard. I'm not quite sure if I can find a default method for this. Second of all, future work would include, I'm now working on a validation study to validate the insights I found with this project lead. And another thing is, I could try to find some alternatives for this session calculation. Right now, it's done based on parameters that should be given by the experts. And on the one hand, this is good because every project is different, every team works differently, so you might need this expert knowledge to know exactly what good parameter settings are. But it might be very hard to give like one hard boundary, so maybe fuzzy parameters would be better. Or I could try to make it into a clustering problem, but then you still have problem like how many clusters do we need? How do we take into account that collaboration should be close in time, and so on. And lastly, maybe an optimization problem where you minimize the time between events within a session and maximize the time between two different sessions. Okay, thank you very much for your attention. If you have any questions, the code is also available on GitHub. If you're interested, you can take a look at it.
Thank you very much for a very structured and clear presentation. Question? Please shoot. I think the acoustic is good if you're loud enough.
So your method is very much governed by objects, digital objects. I wonder a little bit how this could generalize to all kinds of data sets that you obtain from processes, for instance. So, I mean, suppose that you would take a case as an object. Would this still work? Or how much do you rely on, like, exactly these objects? And what would happen, for instance, if, yeah, you would know that there is collaboration between people, but yeah, you might not really capture that in data through this, because there is no digital object, for instance. We just sit together and talk, and we have a brainstorm on a piece of paper, whatever, then you might not have that data. So how do you see that kind of limitation?
Okay, one assumption is that we have to have this data. We have to have data on when they worked on an object. If it's just in the real world and it's not captured digitally, we cannot use the miner. So that's one assumption. Otherwise, the kind of object you use, it could be anything. As long as it's logged, you can use it. So for example, as if you said, you have different people working on the same case, then you can mine people working on the same case. So the granularity should be included in what you make your object. Okay, let me think of another example. For example, if you're writing a book and you want to visualize this, you can make the object the book. Then you have just a network of everyone working on the book. Or you could make the object on a lower granularity level, like the chapter. They have people working together on a chapter, or different subsections. So depending on what you want to visualize, you have to have first data on it, otherwise you cannot use it. And maybe you need to do some pre-processing so you get your object on the right level. Does that answer your question?
Yeah, I just wonder to some extent if you, suppose that you take a case as an object, right? How strongly would your approach differ from the techniques that you described in your literature study, for instance, right? The handover of work, I think network structure-wise, it would come quite close because you define the relationships based on those collaborations, right? And then you add RFM values on top of that. But I think the handover of work model might then become quite close to what you propose here, depending on, and I mean, I could give another example. A case is now very extreme, I think, because it's typically over time, right? But suppose that I take email as an object, right? That could also be something, and then the granularity is much smaller, and then I'm not really sure how that would translate to the graph that you would see. Yeah.
Okay. So handover of work is on activity level. So you have different activities. The problem with the traditional handover of work, it's usually one follows another, and they are connected. Well, these can go way over time. You can work on another object in between, and then back on that one. And I tried to do some handover of work, and you can actually like skip activities. You can set like a skip parameter, but still wouldn't exactly capture the irregularity of working on different objects. You work, for example, on one object, you work on several others, and back on that. But it might still be in the window, and it would still be collaboration. But if you have handover of work, then it just goes from one object on the next. Is that clear? Wait, and also emails. You mentioned emails. You could do this based, for example, on email threads. Usually you start an email with a subject, you have a reply and someone else replies and someone else sends it to someone else and someone else adds a document. So you can do this based on email threads. So every object would be an email thread, and you can visualize like these people work together on this topic of email and these people. If you just take email as is, then you get just a big network, everyone is connected. So you need to have some kind of granularity measure that you can see different groups to be interesting, right? Otherwise you just get a big graph, everyone is connected, that doesn't really show anything.
Okay, further questions? Thank you.
Yeah, thanks for the presentation. I wonder a little bit, do you see any risks in your research? Because you are now analyzing the behavior of people and so on, and what I'm thinking immediately about is privacy.
Yes. Yes, of course. It's a very sensitive topic, because imagine you're a manager and you're analyzing this and you want to fire someone. Is it really a good thing or a legal thing to fire someone over such a graph? So I would recommend it to improve your teams. Like you see that someone is not really collaborating with the ones you thought they were, or you rearrange teams. But I can really see also a threat in like misusing it, maybe, for analyzing or micromanaging your personnel. So yeah, it should be used with caution. I'm not sure how I can avoid this though. So if you have good ideas, like maybe you can.
Yeah, so generally if you talk about privacy, the solution would be not to gather such data, because yeah, keep the profile low of the people. But then your algorithm doesn't work anymore, I guess.
Yes, but also can we really stop the data collection? It's my question. Like you have Google Docs, they also keep track of who worked on the document at what time. So we have that data usually in a lot of companies.
Yeah, but that's the American perspective, I would say, because they just get everything of data. And I think this is also the reason why many European companies don't like if you use Google Docs.
Okay, yes, I agree.
Thanks. Further questions? The third presenter will not show up, so we can go with another round. You have another? No? Yeah.
So you did some clustering, right? And you said that the export needs to set those values. And I wonder, why didn't you use some classical clustering algorithms there, but rely on someone putting in something?
Yes. At first, it was just the thing that popped into my mind. Like before, I thought, oh yeah, maybe I could also use clustering. But at the same time, I was thinking like every project is so specific and every team works in different ways. So if you use clustering, you first need to know you have this timeline of events and we need to cluster this. We need to take into account like still the timing, like it should be collaboration can maybe not be over 3 weeks. It wouldn't be a collaboration session anymore. Usually you sit together with people for a couple of hours. So we need some kind of a way to incorporate this timing constraints, and also how many clusters do we need? What is a logical number of clusters is also very dependent on the way that people log things, the way that team works. So I think it would eliminate the expert, but I don't know if it would lead to better results. So I could try to do this and compare this, for example, make one like this and make one with clustering, then lay it to the expert and ask like, which one do you think makes more sense? So that would be a good thing to comparative research. Sure.
Yeah, and then deadline, may I? Okay. It's not meant to roast you or something. But so I wonder, you do some kind of prediction that people are collaborating. Did you also have a look actually there if there was really a collaboration or it was just a coincidence?
Yes. There were some like links in the graph that, because when they collaborated once, it is shown in the graph, which may not be very interesting. So I took a look at at connections between people that didn't seem very logical. And it was usually then on an object that is very general, like everyone works on this, for example. So it could be fine-tuned. Also, there was another thing I wanted to say. Wait. What was your question again? Yes. Okay, I remember. I also plan to do a validation study, so I contact the team leader to. We now have insights that we can intuitively, we know that this makes sense, but maybe there are some things that either don't make sense to the team leader or are very interesting to the team leader. So I need to do a validation with this project lead to actually know if it's useful, what they see could still be improved, or other things. Oh, okay.
So you make a prediction that there is a collaboration. So you said it could be that they are working in the same document, and everybody was working there. Maybe you have also cases where they just accidentally were working on the same thing, but never were talking to each other. So for me, collaboration means they are working with each other.
Okay, this might be a limitation. Like we do this based on object level within the same time window. But if they're working in the same kind of object, if you take like a latex document and someone is working on chapter 1 and someone is working on chapter 2 and they don't have anything to do with each other, then it might still be shown, but it would not really be collaboration. Yes, so that is a question of data granularity.
All right. Yeah, and it also, I think, it's your notion of collaboration that you introduced, right? And they are working in a specific time frame on one object, kind of. And of course, if you change the notion, then everything, the results will also change. Further questions? Yes, please.
Thank you for the nice presentation and also nice discussion. So I think you talk about the privacy, security things, but I think you can also look at other situations. So for example, a lot of the disaster management. So basically, when you have a disaster management, a lot of failure about the rescue is about the lack of the communication. So this is probably you can look at that cases. But the challenge would be maybe the data you collected is not like what you have in the events. So I think you probably can change your view on the application.
Yes. I think, yes, first data quality is very important if you want to get something useful out of this. And also it could be, yes, indeed good for cases in which you have a project that failed miserably and you want to know what the causes are, if it's bad team management or bad collaboration, then this would be a useful tool.
I think if you analyze that kind of situation, you probably won't get the perfect data set what you are currently have, but you need to probably have the much more strategic data cleaning strategy before you actually start to mining. But actually that have much more impact on the realistic openness of the data.
Okay, that's a good suggestion. Thank you.
Thank you. Further? I also have a kind of a comment. So your talk also triggered kind of the direction that Simon had with the privacy, of course. But if we kind of ignore privacy aspects, I think it would be also interesting from an organizational perspective kind of to also, and maybe that is also a nice transition to the next presentation, to take, because you started from a temporal view and then you went into the graph, into the static kind of view. And actually, I think it would be also very interesting as a follow-up to again go into the temporal way and see who stopped collaborating or who started new collaborations. And that's, of course, from a privacy perspective, also very critical because then you really recognize also maybe things like people don't like to work with one another anymore. And then from a management perspective, this might be very good insight and you can maybe sit down with those people before kind of it escalates. So there's some nice, I once was at a keynote, they mined or they analyzed when Springer did update a new entry on their homepage, a news entry. And they even analyzed and were able to figure out who has an affair with one another, because they always pushed at the same time frame. So this is, of course, privacy related, but I like the research. And I think from a do you think about that, going into a temporal analysis afterward?
Yes, it popped into my mind at one point, but then it left again. But now it would be interesting to have like some kind of moving graph where you can see from time perspective how it evolves. Yes, of course.
You would create, I assume, different graphs for different timestamps, and then you would analyze the delta and what new edges appear, which edges disappear, and then you can do some queries on that. Maybe we'll learn something in the next presentation. So thank you very much for the presentation and the Q&A, and we move on to the next.